I'm going to present our project design of diaper real-time monitoring system based on MQTT and API. My name is Yu Chunzhu from the Department of Information Engineering at Yisu University. My presentation will cover 4 parts: introduction, system architecture, implementation and methodology, and finally, results and conclusion. Diaper thermometer is a common form of seeking information caused by prolonged exposure to moisture, urine, and feces. Continuous contact with urine and feces raises thermometers. Machines infect healthy and comfort. Current clinical care range depends on scheduled diaper checks, which may delay planning checks. Traditional care methods are time-consuming and increase caregivers' workload. Our purpose is to develop a real-time diaper release monitoring system to reduce diaper thermometers. We integrate sensor with I-433 and MQTT for instant diaper status reporting. We also implement a database and API for historical tracking and analysis. Finally, we provide cross-platform monitoring via web and app, so caregivers can check anytime, anywhere. For the hardware, we use an ECBIOS microprocessor due to its small size and strong stability. The sensor modules includes a detector and a lens. The detector identifies the diaper conditions, whilst the lens checks dozen and LED alerts. For server, we use Sony with microprocessor to program the ESP32. MQTT is used to verify messengers. We also use them to set up the website. Finally, we develop application with VS Code and Flat. The system is a smart diaper monitoring system based on IoT architecture, divided into 4 layers: processor layers, transport layers, data processing layers, and application layers. Processor layers. Each diaper is equipped with a cumulator, sensor, and a detector. When the sensor detects urine or feces, the detector sends a signal I-433. Transport layer. The I-433 sends the receipt by an array modules. The array modules checks both a local arrays and microprocessor, which send the detect data via Wi-Fi to a router. Data processor. The router transmits data to a central server using an MQTT protocol. The API servers process the receive data into async with device modules draws historical diaper data. App and web modules handle requests and display results. Application that configure or use counter diaper conditions in real-time growth. Marble app web interface. This interface connects via Wi-Fi and retrieve data from the API server. We recruit sensor activations, timestamps, event events, and delays. Data was stored in a database, including user information and display status. We compare latency between MQTT and HTTP elevator, alert, accuracy, and stability, and analyze change in the diaper thermometers incidents. Performance as your MQTT average delay of 0.3 seconds compared to 1.2 seconds for HTTP. The system runs the bell with multiple lights. The table presents details comparison of neonatal intensive care data before and after improvements measures, including the total number of patents, the number of diagnosed with diaper dermatitis as admissions, those who developed diaper dermatitis after admission, those with recurrent less than 1 month after discharge. It also surveyed the corresponding increased rate, all of which show cinematic fracture reducing following the improvement. In conclusion, we developed a real-time smart diaper monitoring system with low power consumers, real-time response stability. Its effect reduce diaper dermatitis incident and improvement care hurt. We believe this system can be not only to infant care, but also to earlier care and hospital monitoring. By combining IoT technologies are healthcare. We hope to contribute to building smart and more human centered medical environment. In the future, we plan to upsize hours and enhance service functions. Thank you for your attention.
Okay, thank you for your nice presentation. We have 3 minutes for question or comment. Okay.
How does the sensor detect feces and urine?
The sensor detects neutral level use conductivity. When the diaper comes with urine or feces, the moisture increase electrical conductivity, and the sensor detects this change. We can also identify different singles patterns because its structure and texture differ from user.
Okay.
Thank you.
Okay. Any?
If MQTT is better than HTTPS, so why do you still use an APIs?
MQTT is merely used for real-time data transmits between the device and the servers. However, the API is used for data store, control, and analysis in the backend. In other words, MQTT ends with real-time communication controls, where the API allows web and app perform to access the display the data on wherever.
Alright. Have a question? No? No question. At this time, we will move on our next speaker.